Hi everyone, and welcome to another tutorial of the TaskGen tutorial series. So today we'll be focusing on how you can imbue your agents with functions that come from other agentic frameworks such as LangChain, Llama Index, Crew AI, and also how to use the inbuilt TaskGen code generator and debugger for your tasks. So this expands a lot of the capabilities of the base agent, and you need not even limit the functions to those that are provided by TaskGen. You can use the existing functions from other frameworks. So this is going to be huge. So let's take a look at the tutorial. First, let's do the necessary steps. Import TaskGen, import required functions, define your own LM, and so on. And let's continue. So you can see that the first one, let's do Crew AI. So Crew AI has this query PDF tool, which you can, ask, does basically perform RAG on a PDF. So to run this, you first need to install some Crew AI dependencies and so on. So let's run this function. So essentially, all you need to do is to define a Python function yourself, pass in the required parameters that are taken by these external agentic frameworks, the function. So over here, we have the query that is taken by Crew AI. So what we need to do is to just wrap the Crew AI function directly inside your own Python function like this. And just remember for the doc string, mention the variable over here so that the TaskGen side can make this into an equip function. So over here, we download the React PDF. We can use the tool directly now, like what is React? And here the Crew AI tool will return the relevant content and so on. Let's assign this function to a PDF query agent. Print out the functions. You can see that now query PDF tool is wrapped inside a TaskGen equip function with the description, return the answer to the query that is a string type, which is all inferred automatically by your Python function. So it's really, really easy to integrate tools. All you need to do is to just wrap the tool up in your own Python function, and that's it. Right? So we can run the agent. We ask, what is React? And now we use the modified React framework because here the observation is all the subtasks completed. Okay, thoughts, and then the subtask identified, and you can see that we search the PDF content based on this query. So I really like this because this is like adaptive RAG where, you can ask different questions based on what is needed. And, at the next step, they will find out, do I have enough? So if I have enough, I'll end. If not, I ask some more. So this, I also have other names, right? Like on-demand RAG and so on. This iterative RAG or on-demand RAG is super powerful. So I really like this kind of thing. So we can now reply the user based on what we extracted from the React framework. Plus, we could extract more chunks and so on if you configure the Crew AI function here accordingly. And you can see the reply framework. This is the React framework used in iterative decision benchmarks such as Alpha, Web Shop. So it's pretty good. I mean, because the chunk that's extracted here is pretty good as well. All right. So what if you want to do other tools? Okay, like the script website tool, which is actually, by the way, Crew AI has a lot of great tools. I recommend using them. I love using the Crew AI tools. So over here, we have the website summarizer that uses the script website tool from Crew AI. And let's see what are the differences between TaskGen and Crew AI. Let's just run this. And first we go to TaskGen, get some data. All right. Then we go to Crew AI, we get some data. All right. This is, by the way, a TaskGen agent, not a Crew AI agent. Crew AI will take much longer to do this because they're using a conversation. So now we analyze the script data from both TaskGen and Crew AI. You can see this, the LM generated summary, and then generate a concise summary. Okay, good. So now we have even more concise stuff. And okay, so over here, it's trying to make it even more concise, but that's why we have a max subtask, because sometimes the agent doesn't know when to stop. So after a certain time, you should stop it. And we can now reply the user about what the different things that we have extracted are. So like, for example, we can ask, like, what are the key imports needed for both frameworks? So we'll analyze that subtask completed. And you can see the script data, we don't really have the imports needed because TaskGen just imports everything. So maybe I should change the documentation to make it more specific. But Crew AI, you can import like agent, task, crew, process, and so on. And yeah, this is what the comparison is. So like what version of packages are they compatible with? So pip install create I, and then okay, so for TaskGen does not provide any specific version compatibility. Okay, this is because TaskGen itself, we actually have the dependencies not in the original README. So in this README here, I did not really put the dependencies. Okay, but if I did, then this question TaskGen will have more answers for this part. All right, but overall you can see this using of external tools and putting in an agent is really very simple. All right, let's go to LangChain. So LangChain allows you to define your own functions like this with an add tool, and then in order to use this function, you can just simply put .func, and this will automatically give you the Python function needed with all the inputs and outputs accordingly. So all these are inferred automatically by TaskGen. Then we can do stuff like calculate 3 times 5 plus 3 because we gave the add and the multiply functions. So first we multiply, then we add, and we get the final answer. So what if you want to use LangChain community tools, which, by the way, it's not bad. It's not bad, really. For some tools, it's not bad. Like Wikipedia search tool, awesome. If you want to search Wikipedia for something like Joe Biden, you've written all the information about Joe Biden from the page here. So I summarized to 100 because it's a really long chunk, so 100 characters only. Okay, so all you need to do is the same thing. Wrap your own Python function and put in the input variable needed for the function that you are taking from the external agent framework, and put it inside over here. All right. And over here, do the doc string that contains like the word search query. So you can see this is how we run it. We also have the Python REPL tool, which basically runs Python code in a limited way. And you can see like you can run like print 3 plus 5. Again, you just need to wrap it like that in a Python function. Really, really easy to use. Go try it out yourself. All right, Llama index. Okay, Llama index has user functions. Okay, like this function 2 from defaults. All right, you can use your own Python function like this. So if someone has created community tools that are using this method, you can just do to.function to get it back to TaskGen. So I have not done the thing for other kinds of functions, but essentially it will be the same thing as LangChain or QAI. You basically just wrap their function inside a Python function, and you just pass that Python function to TaskGen agent, and that's it, right? So here we have TaskGen custom tools. So I wasn't too happy with the code generation and debug tools for the other frameworks, so I created my own. So what we have here is we have a Python generator tool, we have an executor tool, and we also have a debug tool. If the execution failed, the error message can be passed to the debugger, and in some loop of 3 iterations, you can configure it. We can do the error debugging and code correction. So first up, this is like we just pass in a generic shared variable so that we can test out this agent later. So we have the Python generator tool, then that basically has the following imports: math, numpy, random, datetime, re, regex basically, matplotlib, pandas, plotly. You can add your own here so that the code generator can use more imports. All right, why do we need to define all this? Is because I prefer if we have safe code execution and we only limit the libraries that the code can use. Okay, you'll see why this is used later. All right, so over here, down here, we just use a strict JSON code to generate the code based on the instruction. All right, and basically we have all the functions of the agent as well, so that you can use this code to run your agent's functions if needed. Okay, but if you want to keep it clean and not use the agent's equip function, then you don't have to have this here. Okay, but I just put it here just to make it a bit more robust so that inside your code you can do a for loop and run your equip function also. So this is useful when you are doing like code agents or code as actions, where you, instead of using an equip function directly, you generate some code to run your functions. So this is actually meant for that. You can actually remove this part if you don't want it. Okay, so this is the Python generator tool, and in the end, what we come up with is the generated code. All right. So you can see that if we ask for what are the, oh, sorry, I forgot to run this. We asked what are the first 3 primes. You can see that they imported the Wikipedia tool and search the Wikipedia results. Okay, so this is actually not what we really wanted. So what are the first 3 primes by calculation? Oh, okay. Over here, I see why, because like they think that you have to use the equip functions whenever possible. Yeah. So over here, Wikipedia 2 is it doesn't really help with the calculation part. But if we specify like by calculation, you see they use import math and so on. So this is why sometimes giving too much stuff for the agent may not be great. You might want to take this out if you don't want to use your equip functions here, which is in this case the Wikipedia 2. All right, so now we have the code here. Let's try to run this code. And how do we do this? It's using the Python run tool. And what we can do here is we can basically say that, hey, we declare all your external functions here so that you can use your external functions in your allowed globals. All right, then we have a list of safe things that you can, or rather, I think this is pretty safe. All right, if it's not safe, feel free to remove things that you don't want. Okay, and then we put in like math, datetime, random, numpy, plot, matplotlib, pandas, plotlib. You can put in your own stuff here based on the prompt that we saw earlier over here. All right. So you can see we have all this, and then we basically run the code. And if there's any error, we capture it, right? And we put in the output. So if we run a tool, like this is a great tool to debug and run code, you can see it ran this code and it printed out awesome as well. And now we have the Python debug tool, which is basically taking in the instruction that we have, the Python code that we have, and the error message, and ask it to do the corrected code in a chain of thought manner, like ask it for thoughts and how to, and the final code. And you can see here we have a code missing a /n, and you see the thoughts is that, yes, syntax error, it should be separated correctly, and the corrected code is correct. So you can combine all this, and I call this Python generate and run code. So basically, it just takes in this few modules that you can use and all the equip functions and so on. And what it does is that it basically asks the Python generator tool to generate some code. Okay, that also in the instruction, I will append all the previous subtasks completed so that this tool knows what has been done previously and what failed. All right, so we generate the code. After that, we run the code. If there's an error, we debug it, and this runs in a cycle of up to 3 times. All right, and in the end, we just call this function here and make it compulsory, because we want this Python generate and run code to work even with the function rec that you see in the tutorial 4. Tutorial 3, the memory part. Okay, so we have this, give me first 10 primes without 2 and 5, and here it's using the filter function name, again, this Wikipedia 2, but it's not useful. So what it did is it used the math function and so on. So this is great. Okay, just take note, it's using the math function because we only limit it to all this. You can change this in your own, of course. In the future, I'm going to create a wrapper for this code so that you can wrap your agent inside this wrapper. And you just specify what are the modules you want, and we will automatically do all this for you. Okay, and then in that wrapper, I'll probably also put, do you want to use your agent's inner equip functions? So if you want to, then the code can use it. If not, the code will not use it. I highly recommend that you don't really use the equip functions for your agents, because it can lead to complications when your agent executes it wrongly and so on. Okay, I'll cover that more later in the code action part. All right, so you can see you can generate the primes here using the math. So output 1 here, you can see this the output for your code, and output 2 is the code itself. In the function for generate code, I've instructed it to print out the answer so that you can see in your output 1, which is the printed answers, you can see that your answer will be there. And output 2 is just basically meant for the agentic structure to know what code was used to get this. All right, let's show the general CodeGen agent showcase. We have the Wikipedia tool, and we have the Python generate and run code tool. And let's do this for some stuff. So first, we have a math problem, like John has 5 apples, receive another 21 more from Mary, gave 10 to Tim. How many does John have at the end? If you don't use code for this, LMs might get it wrong because they are not very good with math. So over here, you can see that we have initial apples is 5, and then giving apples is 10. What we do is final apples is initial plus receive minus given. So you can see that the final answer is 16, which is like 5 plus 21 minus 10. So code indeed helps a lot. We can see the answer is 16, and we can reply the user and say that, okay, John has 16 apples at the end. Absolutely wonderful. This is how we can integrate code seamlessly with the prompt. And just realize this code here is not hard-coded at all. It's generated by the LLM using the Python generate and run code tool. And if there's any error with the code, you can iteratively correct it up to 3 times. Or if you want to, you can just change it yourself, the number of times. But it's really cool how it can generate arbitrary code and execute it in a relatively safe environment because we limit the imports. So now we have other stuff like plot me a graph of y equals to 2x squared, and you can see they generate and run this graph, and you see it's done. So you can see the graph here. Oh, cool. It uses the matplotlib to do it. Automatically done even without you telling it how to do it. What are the first 10 prime numbers? Let's see what it does. And it uses the math tool. Awesome. Well done. Okay, well done. And then what we do next is, who is Joe Biden and how old is he? So you need to use the Wikipedia tool to search it. So Joe Biden is born in 1942. After that, we need to do like how to calculate, and we can use the generated code to say that, hey, using the date time now, which is like 2024, you minus off 1942 and you realize that his age is, I think it's 84. So you can reply user and find out the answer. And you can see, okay, is the answer somewhere here? I think it's 81 years old. Yeah, because of the weight. So you can also say reply only the age, and you can get 81 years old. So this is using date time to calculate. All right. And this is really cool because when you use deterministic code like that, you get better answers. All right. Now moving on to the code as action paper. So, there's this paper that says that if you output code instead of, equip functions and so on, you can actually do more in every step. Like you can do a for loop to execute your equip function 3 times and so on. This, I found that while good at certain domains, in the large scale of things, actually, this is not a very reliable way to do it because the debugging process is a bit harder. But anyway, if you want to use it, it's not that difficult to do. What you need to do is, in the TaskGen itself, you just need to equip the Python generate and run code tool. It must be exactly this name. And then you set your code action to be true, all right? So that this will be the overall function that will be used all the time for every subtask. And what we can do is, we have 2 functions now. One is the generate and run code tool, and one is the return random person function. And because when you set code action is true, we will always use this function. So this one will become like, the equip functions that can be used in this code. So let's say we want to generate 3 names at one go. Let's see what happens. And you can see that we call random person 3 times. And here we have the output of it being called 3 times. And you can see the code here is just really just calling return random person 3 times. And the answer is complete. We can reply the user, what are the 3 names? And you can see the answer. Oops. I just deleted it accidentally. So let's just run this again. So you can see that the answer is, okay, they gave all the things like the code and everything. So reply only the 3 names. So that's why, this reply user is awesome because, you can control how much you want the reply to be. So Edward, Alice, and Don, exactly what we have output over here in 1 step. So if we did not use this, this code action thing, you need to run the return random person 3 separate times. So that can add up to a cognitive processing length that is much longer. So there's some merit to code as action, especially if you need to, run the equip functions many times. But generally, my advice is that if you need to run a function many times, you just put in the variables for that function, you just put like a count. And then basically that count will determine how many times you run that function. So, this makes it more reliable than just simply generating code like that to run it. But all in all, this tutorial here just demonstrates how we can use TaskGen to do code generation, how we can use TaskGen to interface with existing frameworks like AI, LangChain, Llama Index, and so on. And this means that TaskGen is pretty much a plug and play. You can just plug and play functions from anywhere and just put it in the TaskGen framework, which is much more efficient than other agentic frameworks. So with that, I'm signing out, and I hope you have fun using TaskGen. See ya.